Okay, so finishing up where I left off. So again, the reason I used parentheses here was because I need whoever's to look at this to know that this Q4R all went together up here. Now, if you want to be extra safe, you could put a parentheses around the first part as well. So you can tell whoever's looking at your problem that, hey, all this goes together just like all this goes together. But then together they go as division because it's a subtraction in between. All right, moving to the next example. I've got log A, fifth root of U2 over V3. Now, I need to get rid of this fifth root. To get rid of this fifth root, this 5 becomes the bottom part of a fraction. Now, for this example, that's going to be on both. So it'll be U2 to the fifth over V3 to the fifth. All right, so now I've gotten rid of that square root symbol, the fifth root symbol. Now I'm ready to start separating. To separate, I see fraction here. So fraction is division, so that means I need to subtract. So that'll be log A of U2 to the fifth minus log A V to the 3/5. Okay. Now both of these have exponents. There's no multiplication here, just exponents. So exponents go to the front. So this will be 2/5 log A U minus 3/5 log A V. And now I'm done because there's nothing left inside the log to move anymore. Okay. All right, next example, in the last ones, now we're going to express them as single logarithms, meaning I'm going to get these back down to just a single log. Now, order that I go in is I start with anything in the front. So if there's anything in front of the logs, I turn those to exponents because something in front means that it was an exponent originally. So this 3 is now going to come up, this 2 is going to come up, and this 3/2 is going to come up. So that'll be log, I don't know why they keep using A's because I'm not drawing my A's good today, it'll be x to the third minus log A y to the second plus log A z to the 3/2. Okay. All right, from here, I'm going to go ahead and do the addition next. Okay. I'm going to leave log A x to the third, and I'm going to put these together. Addition means that they were originally multiplication. So I'm going to leave this minus log A of y squared z to the 3/2. I just put them together with multiplication. Now I'm ready for subtraction. Subtraction means that, hey, I'm going to have to divide these two things. So that'll be log A of x cubed over y squared z 3/2. Okay. All right, so the last example. Again, I'm going to start with anything that's in front of the logs. So I'm going to have to move this 2 to an exponent. Nothing in front of that log, nothing in front of that log. So that'll be log A of x squared. And then bring down everything else. Log A of x minus 3 minus log A of x plus 3. All right, starting with addition. Addition now becomes multiplication. So that'd be log A of x squared times x minus 3 minus log A of x plus 3. All right, so now this subtraction between them turns the insides to division. So this will be x squared, x minus 3, all over x plus 3. So now I took this, what was really, really big equation, down to a simple expression, actually. Not equation, expression. I got it down to a single expression. Okay, starting with the exponents that are in front, turn those to exponents. Then I start with addition, then move to my subtraction. Okay.